Hello and welcome back to part 10 of my algorithms video tutorial series. For the sake of completeness, the last algorithm that we haven't really covered is Quicksort. And as you can see from the code that I wrote for Quicksort, it's not a simple algorithm to follow. So Quicksort is a little bit more complicated than some of the others. It's a bit of a divide and conquer algorithm in that you pick a pivot and then you move all of the items that are smaller than the pivot to the left, and all of the items that are larger than it are left on the right hand side. If we watch a visualization of this in action, what happens when you've managed to do that, you've found the actual position the 22 should go to, and then from there you just do exactly the same on the left hand side and exactly the same on the right hand side. So you end up not needing to compare absolutely every single item against every single item, and you save comparisons as a result, making it quicker. The code for this is more complicated than I'd care to explain, so I've put a download link in our Schoology page. The other option, if you're not from the school and you want to do it, is that you can pause the video and you can simply copy this code into your program. So the Quicksort algorithm, as I said, a couple of little things I'll just quickly talk about is I made it because it's a recursive algorithm and I want to do the algorithm in place. I had a start and an end point, but if you leave those completely blank, if you just pass in Quicksort and then the list when you want to sort the whole list, then it'll work perfectly fine. It just needs these values in order that it knows which is the next part of the list that it needs to sort. It does return the number of comparisons as well. So when you run the algorithm, the Quicksort algorithm, as I'll show you in a minute, you'll get a result back which should be the number of comparisons that was done to complete the whole sort of the algorithm. So as a bit of a bonus, let's just test this. So we'll start with a list of 10 items. I want to get the Quicksort in there as well, so I can test both selection sort and Quicksort. This my list, I get a random list from my utilities function that gets the random list somewhere. The result is of the selection sort. It prints the list before it and it prints the list after, and it tells me how many it took. So with the selection sort, if I just move this over, with the selection sort, we should have a list of 10 items is printed. It should then sort it, and then it should print out the finished list, and then it should tell me the result of how long that took. So with the selection sort, we get a sorted list, and it took 55 comparisons. If we have exactly the same list, or exactly the same size of list, and we run it with Quicksort, it takes us only 28 comparisons, and we still have, I believe, the sorted list. So just really quickly to do a simple comparison, I decided I would write this little bit of code as a bonus for you to have a little look at. So I get a random list, and it's important that you copy and do like a deep copy of this list so that you have a complete clone of it before you test it. Otherwise, the test isn't very accurate if you're testing on a different list. So rather than create two random lists, although I don't think it would make a heck of a difference, but I copied one list into another list. So I've got my list and then another list, and then I do a bubble sort with the first list, and then I do a quick sort with the other list, and I store both those results. And with 10 items, you can see that the worst performing bubble manages to get 90 comparisons compared to a quick sort 31. And you want to look at maybe what happens when you double it or triple it or quadruple it. So running it now, you'll see that the bubble is starting to get quite a bit worse when the Quicksort manages to go up, not in a linear way, it still goes up slightly exponentially, but significantly less than you would see when you had, let's double it again, when you see for the bubble sort. And obviously you've got selection sort that you can do too, so you can do lots of comparisons to see how efficient and how quickly those algorithms manage to sort the data. So that's it for the video series. Hopefully you've got enough in there to have done some coding, written some algorithms, even if you maybe don't understand them all entirely. And your job is to make sure that you write some analysis code for these algorithms to be able to either write more utilities if you need to, or be able to create some CSV output, some graphs that compare the performance of these algorithms as the size of the data increases, and possibly an analysis of a comparison between algorithms and some possible explanation for why and how the algorithm is more or less efficient.